the solid of revolution, and we will cross this out. I thought our solid of revolution will do the cylindrical shell method today. The formula for it is the volume equals 2 pi times the integral from a to b of x times f of x dx. And we'll cross out this. Okay, so go all the way back to the beginning. Okay, so when we have the formula right here, and pretty much the cylindrical shell method is just taking a curve with area under it and rotating it around the y-axis instead of the x-axis. So that's just basically what it is, cylindrical shell. So what it'll look like from above will be, it'll be like a cylinder from the outside, and then a bowl on the inside, so like kind of like dipping in. I don't really know how to draw that, but yeah, that's a poor drawing, but it's going in. Let's show some depth to it. So it's going inside. So it'll be a bowl, but a bowl on the inside, cylinder on the outside, if you know what I mean. So that's what it would look like from the top view, looking down on it from here when it's already rotated. So an example, f of x equals x squared, which is this curve right here, from 0 to 2. Volume equals 2 pi times the integral from 0 to 2 of x cubed dx. The reason, x times f of x is x squared, x times x squared is x cubed. So simple antiderivative. Oh wait, nope, no, we don't want the derivative. We already integrated it. Well, not yet, but we're about to. Okay, so the antiderivative of x cubed is x cubed over 4. From 0 to 2. 2 to the 4th power, if you don't know that already. Maybe do, maybe don't. It's 16. 16 divided by 4 is 4. 2 pi times 4. Make sure you never leave out the 2 pi, because that can mess up the whole thing. You'll be 2 pi. I mean, if you forget the answer, forget 2 pi. Whenever you get your answer, you can just multiply by 2 pi, whatever. As long as you get the right answer. And 4 minus 0, because 0 to the 4th power is still 0. 0 divided by 4 is still 0. 4 minus 0. 2 pi, alright, 4 minus 0 is still 4, so just 4 times 2 pi, very short one. 4 times 2 pi is just 8 pi. And there we go. And there's also, you can do the cylindrical shell method, except around the x-axis, except it will be functions of y, so it will look kind of strange, but it will look like this. You have your graph, it will look like that, and the area under that curve, which is, it's not under, we're used to taking the area under the curve because it's dx's, it's along the dx's, these infinitely small changes in x. Instead, it's infinitely small changes in y, so dy, so it's the area to the side of the curve. And this rotated around the x-axis. And you'll have, from looking from the right of it, looking in, you'll still see the same bowl, but it'll be kind of rotated. It'll be rotated, yeah. So when you have that, it'll be just switching all the variables of x with y and y with x. So I'm not going to do an example, but the formula for it would be times 2 pi integral from a to b, which a to b this time will be points on the y-axis. I should say b is 4 and a is 0, and the line y equals 4 and y equals 0 instead of x equals 0 and x equals whatever it usually is. In this other case up here, x equals 2. So from a to b, or c to d, whatever you want to do, of y times f of y times f of y, dy. And f of y is just x, so you could say xy. So really, if you wanted to do this rotated around instead of rotating around the y-axis and around the x-axis with x squared, or whatever it may be, let's just say y equals x, then, or no, we'll just say whatever, f of x equals x squared, doesn't matter. That means that integral of xy dx, and that's the same thing over here, yx, because x equals f of y, except y, that if f of x equals x squared and then you flipped it around, f of y equals y squared, so it won't be the same thing except dy if you were to take this and to turn into y squared, but you would still you'd still be rotating around an axis, just not the y-axis. It will be around the x-axis. So making too complicated as it should be, but it's just switching around the variables because you're switching around a different axis. Because we're totally used to rotating around the x-axis, or at least just finding the area under a curve, not to the side of a curve. So it may be confusing, but if it's confusing, just stick with the first method of going around the y-axis and use cylindrical shells, or not cylindrical shells, the washer method or this method to go around the x-axis instead of the y-axis. And that's it.